All right, let's take a look at kind of just an overview of the activity for last week, where we're getting the elastic energy from Hooke's law. So I'm going to use Afton's lab that she submitted. So sorry, Afton, I apologize if I criticize you at all in this. All right, so here's our first graph. Force applied is delta x. According to EOL, the spring constant should be 30 Newton meters is correct. So it's just the slope with the units. So that's good. Okay, then you had to calculate the area underneath it. Okay, and then that graph ended up being with a curve to it. I don't know if I can change that. Just see here. I'm just trying to. Okay, so here's your original graph like this, and then I would have made this, call it change in length squared. You have to square the bottom to get that to become a linear graph. All right, so EOL for this, so elastic equals 14.8, and that needs units, and so it should be, it's not quite right, so elastic is 14.8. That's going to be joules over meters squared, right? Let's look at the units here. Right, joules over meters squared. Okay, and that's times delta x squared, which is meters squared. So that's kind of what your slope is going to look like. And this simplifies, joules per meter squared simplifies actually to Newton meters. All right, then you do part 5. What type of relationship we have here? It is a square relationship. That's good. So your springs and the original one is 1/2 the original slope value. So it's 30 Newton meters, and now it's 15 Newton meters. So it's 14.8, so it's pretty close. So the mathematical model, elastic energy is 1/2 K, and then you need the rest of it. So that's going to be 1/2 K delta x squared. It's going to be what this should be. Okay, so just to kind of review here, what we have for our toolbox. So we have the first one from Hooke's law, force applied is K. G, put these in there. K delta x, so that should be in there, that's Hooke's law. And then we had E elastic, that's what we just came up with, is 1/2 K delta x squared. Okay, so make sure those are in whatever toolbox you have you're using with. That's what we have so far. Today's activity is going to be involving using this elastic energy.